So this is section 4.4 day 3. So like I said, we're going to be finishing this up today. And basically this is the last day of proofs. After the quiz on Friday, what we go on to will not be proofs. So once you take your quiz Friday, you're done with proofs for the year. So if you don't like them, you'll be done on Friday, okay? All right, so first of all, I'm just gonna review the different ways that you can show two triangles are congruent. The first one is side, 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 and that's pretty obvious. The second one is side, angle, side, and the important part here is your angle has to be in between the sides. Okay, that's super important. And then when we look at the next one here, we have angle, side, angle, angle, side, angle, and your side has to be in between the two angles. So this side has to be in between the two angles. And then for angle, angle side, the side is not in between the two angles, okay? So we're gonna go over a couple proofs again today. So let's copy down the given for this one. Segment ST is parallel to segment RU, and segment SR is parallel to TU. And those are given. So what that tells us is these two are parallel as well as these two are parallel. All right. Now, what did we talk about? When you have parallel lines, what kind of angles are we looking for? Alternate interior, correct? So if these two are parallel, that makes this angle congruent to that angle. So let's go and write that down. You have to use 3 letters, and for the top one, T has to be in the middle. So it'd be angle STR is congruent to angle, and then for this bottom one, R has to be in the middle. So angle TRU or URT. Now, because these two are parallel, we have another set of alternate interiors, so I'm going to do that at the same time, okay? And so for this one, this angle right here, I could say SRT or TRS. I'm going to do angle SRT is congruent to, and then for this one, T has to be in the middle. So I could say angle RTU or UTR. So that's RTU. And I can do both of those under the same step. And that is alternate interior angle theorem. Where I see kids lose points on proofs is they don't number the steps, and like on this one they forget to put theorem. So you do have to have that theorem at the end. Now, do you guys see something else here that's congruent? Reflexive. So I could say TR is congruent to TR. And that is reflexive. And here you have to write prop for property. And then now we have 3 things. Remember, the parallel doesn't count when you're doing the different SSS, SAS. So I have three things. I can copy that down. So I can say triangle SRT is congruent to triangle UTR. And remember, when you get to this point, you have a choice between side, 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 side angle, side, angle, side, angle, or angle, angle, side. Now notice on this one, we have two angles and a side. So that means it has to be one of these. Our side is in between the two angles. So do you get that it's this one? Angle, side, angle. You don't use the arrows when you're doing that. They're not a part of it. Only congruent signs are a part of that. Okay, so let's go to this one. So let's write down the given. Segment DE is parallel to segment JK, and segment DK bisects segment JE. Okay, and that is given. Now this is another proof that can be done more than one way. So if that happens on the test tomorrow or Friday, I would know that there's more than one way and I'd be looking for that, okay? Now, we have parallel lines and we have that a segment bisects another segment. I'm gonna deal with that one first. So they're telling me that DK bisects JE. If it bisects the segment, it cuts it in half. So these two would be congruent. So DK bisects that. So I could say JG is congruent to GE. Does anyone know what that reason is if you bisected a segment? Definition of segment bisector. So definition of segment bisector. So there's a definition of angle bisector if you cut an angle in half, and segment bisector if you cut a segment in half. Now this is where you can do this proof more than one way. What would you guys do next? Say that again. Yep, vertical angles. Okay, so let's do those. We'd need three letters, so we could say angle DGE is congruent to angle JGK. Okay, and like Chloe said, that's vertical angles. So it'd be vertical angles theorem. Again, you have to have the theorem on there. Okay. Now, when we see parallel lines, what do we think of again? Alternate interior. And do you guys agree there's two sets here? Which we could have just done those two sets and not done the vertical. That would have been fine. Or you could do the vertical and one of the sets of alternate interior. Should we do J and E or D and K? Does anyone care? Let's do D and K, okay? So I'm gonna say angle D is congruent to angle K, and that is by alternate interior angles theorem. Okay, now we have three things, so we're ready to say that the two triangles are congruent. So I'm going to say triangle EGD is congruent to triangle JG, or wait, no, I'm just copying this, JGK. Okay, and which one is this by? We have two angles and a side. Angle, side, because the side is not in between there. So angle, side. Okay, then I just want to point out, say that instead you didn't use your vertical angles and you used both sets. Say we used both sets of alternate interior angles. That would have been fine. And then it also would be angle, side, because the side is not in between. Or what you could have done is we could have stayed with the vertical angles, and we could have picked the other grouping of alternate interior angles, and that would have been fine too, and that would be angle, side, angle. So that one can be done 3 different ways, and you just do one of them, and then I would know that when I'm correcting it, that it would have 3 different ways, okay? All right, so let's go here, and we have that Z is the midpoint of CT, as well as CY is parallel to TE. Okay? This one is a little bit harder in that when you're doing this, you're not sure if you're going to try to show that these 2 triangles are congruent or these 2. Okay? Because these 2 are our parallel lines, that tells me that these are the 2 that I want to prove, or that I want to use. And then basically you're just forgetting about the other 2. And what tells me to use these 2 is the fact that these are the 2 sides that are parallel, okay? Now let's deal with Z being the midpoint of CT first. That means these 2 pieces are equal. So I could say CZ is congruent to ZT, okay? And do you guys remember what it's called if you have a midpoint? Midpoint theorem. Make sure you put the theorem for that. And remember, you have that cheat sheet which has all the steps, so you can always be looking at that. Now, this is another one that can be done more than one way, depending on if you choose the 2 vertical angles or if you choose the 2 alternate interior angles, okay? So this one, I'm just going to go back and write this for my notes on this one too. All right, so this one, let's choose, instead of the vertical angles, let's choose the 2 alternate interior angles. Okay, again, we have to use 3 letters. So when I name this angle, I could call it angle ZET or YET, whichever I want. Okay, I'm going to say angle ZET is congruent to angle, and it's this one here. which I could say angle ZYC or EYC or CYZ also. I'm going to say ZYC. And then at the same time, I'm going to do the other two, okay? So this one I could call angle ZTE. And then the other one with two arcs, I could call angle ZCY. Okay. And those are alternate interior angles. So it'd be alternate interior angles theorem. Okay. Now, when you go to decide, like, do I have enough? You don't count parallel lines, and all of those have three things in them. So you're looking at, do I have three things marked, and are they one of those? So I have two angles in a side. Is this angle side or angle side angle? Is the side in between the two angles? It's angle side. So now what I'm going to have to do, angle side, I have to actually write the congruent statement here, because notice they want me to do a CPCTC for this. Okay, so I could go triangle. I would go from the angle with one arc to two to none. So I'm going to call this triangle ETZ. Is congruent to triangle. And then again, I'm going to go from one arc to two arcs to none. So I'm going to go triangle YCZ. YCZ. So now that I have the triangles congruent, now I can do the CPCTC. So I can bring this down right here. YZ is congruent to EZ. And that is by CPCTC. This is a harder one with there being more than one group of triangles. I would not put one like this on your test. Okay? All right, last proof for today. Let's do this one. So we have that segment TX is parallel to segment SY, and angle TXY is congruent to angle TSY, and that is given. Okay. Now, if I go over here, I have the two angles that are congruent marked, and I have the parallel lines. When you have parallel lines, you want to look for alternate interior angles. And do you guys get, if these two are parallel, that the alternate interior would be this one and this one? They're the two that touch my parallel lines. Okay, so when I name those, I need to use three letters. So I can say angle XTY is congruent to angle SYT. Okay, and that is due to alternate interior angles theorem. All right. Now, do you see something else that I could mark? Reflexive. So I can say TY is congruent to TY. And that is reflexive property. And then if I look up here, I have to decide how these are congruent. And I have two angles and a side. The side is not in between the two angles, so what would it be? Angle, angle, side. Okay, and then I would just copy down the proof statement. Triangle TSY is congruent to triangle YXT. Okay. All right, the last thing that we're going to talk about today is how you are going to just get a diagram, and you have to say either that they're congruent by side, 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 angle, side, angle, side, angle, 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 side, or NP for not possible. Okay? Now, if you're ever wondering, what can I assume from a diagram? You can always assume vertical angles. Okay? If you have parallel lines, we can always assume alternate interior angles, and in this one, both sides are parallel, so we have two sets of them. Okay? Sometimes you only have one. Anytime two triangles share a side, that's reflexive, the side that is shared. And then here, if you have one right angle, you can assume the other one is right also. Okay? So when you get to this, and this will be on the test, for some reason, like my high school students, either got this or didn't get it at all. So like they did really well on this section, or they lost like 10 points on one page. So your answers for this are either going to be SSS, SAS, ASA, angle, angle, side, or not possible. Okay? So if we look at this first one, is there something else I could mark? Vertical angles. Now I have three things. Are these three things one of these up here? Isn't it angle, side, angle? So that would be our answer. Okay. When I go down to this one, is there an additional thing I can mark? Reflexive. Okay, so I'm going to use 1 dash there. Now, if you look at one of your triangles, do you guys see we have two sides and an angle? The one that has two sides and an angle is side, angle, side. Is that angle in the right spot? Is the angle in between these two sides? No. Shouldn't it be right here instead? Do you guys get that? And then side, angle, side in this triangle, it should be right there. So the angle is not in between the two sides, so then it's NP. Okay, for side, angle, side, the angle has to be in between. Do you guys see something additional here? Vertical, all right? We have three things. Do you guys all get these are angles and this is a side, okay? The ones with two angles and a side are these two. Which one is this? Is the side in between the two angles? No. So it's angle, angle, side. Okay. Here we have two sides and an angle. So that leads us to this one. And check both triangles. In this first one, isn't the angle in between the two sides? But is it in between the two sides here? No. So then it's NP. That angle should be right there. And it has to be true in both of them, not just one. Then if I look at E, do you guys see something else that's congruent? Vertical again. Now, these are angle, 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 angle. That is not one of them. So that's just not possible. We'll learn about angle, angle, angle in chapter 7. Now, in this one, what can we mark congruent? Reflexive. And then don't we have side, 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 right? Okay. Now let's go to our last page. Same thing. Is there something else I can mark in this one? Vertical, very good. Now, this is 2 angles and a side. So it has to be one of these two. Is the side in between the 2 angles? It's not, right? So then do you guys get that it would be angle, angle, side? If the side is in between the 2, then it's angle, side, angle. When we see parallel lines, we can mark alternate interior angles, and this one has 2 sets, so I'm marking those. What else is congruent here? Reflexive. So if you look at one of the triangles, there's 2 angles and a side. Is the side in between the 2 angles? It is. So would you know then you would have angle, side, angle. Okay. Now if we look at this one, is there something else we can mark? Reflexive. Okay. Here's where kids get these wrong sometimes, is they just start marking things so that they have 3 things. Okay? The only things you can mark are back here on this sheet. If you have vertical angles, you can mark them. If you have parallel lines, you can mark alternate interior angles. If they share a side, you can mark reflexive. If there's a right angle, you can mark the other right angle. But in this one that we're on, there's no vertical angles. We already did reflexive. There's no parallel lines, so we can't do alternate interior, and there's no right angle. So there's nothing else we can do. There's only 2 things, so then we just write not possible. For D, is there something else we can mark? Reflexive. And what is this one then? Is that enough? Angle, angle, side. There's 2 angles and a side. Side is not in between, so it's angle, angle, side. Then if I look at E, I only have one of my pair of angles parallel, okay? When you do that and you mark your alternate interior angles, they touch the parallel lines, okay? Does anyone see something else I can mark? Reflexive, right? Now, if you look at one triangle, we don't have vertical angles. We don't have any right angles. We already marked alternate interior, and we already marked reflexive. So that leaves us nothing to add. And if you look at one of the triangles, there's only an angle and a side. There's nothing else on this triangle. Okay, so there's only 2 things, so then you would write not possible. Some kids would want to say on this one that this is angle, side, angle, but these 2 angles are in different triangles, so you can't do that. For it to be angle, side, angle, it would have to be that angle right there. Okay. All right, if we look at F, what else can I mark? Vertical. And what is that one then? Yep, angle, angle, side. if I look at this one, if this is a right angle, this is a right angle, and then I also have reflexive. So what would that be then? Angle, side angle. Okay. All right, now if I go down to the next one, we can mark this side, okay? So we have two sides and an angle. Is the angle in the right spot? No. This one, in fact, you guys, would be angle side, side. And remember, you can't swear in math. So angle side, side is ASA, that one doesn't work. So this one is just not possible. Okay. All right, so your assignment for today is another worksheet. And I have the key up here. I believe I also put it in Schoology.
And you work with a partner?
As long as you're working out. But tomorrow for the practice quiz, we're not going to work with a partner, I don't think.